The robotics subject and its activities are unique and interesting as we can learn the basics of components, learn how the components work and behave, the plans and flowcharts used to guide us in making systems, and learn basic coding to make our projects functional. We got our first activities in this subject, and it's all about LEDs. We made systems that uses LEDs with the guides of tutorials and setting up codes to make them function perfectly. The first activity was the blinking LED, where we put up a code so that it blinks on and off in intervals. Next was the fading LED, where the code setup would make the LED light slowly fade off and then shines again. And these activities involving LEDs will go further until we involve buttons, potentiometers, and photoresistors.
And our next activities in this subject focused on buzzers and 7-segment displays. Each buzzer activity was unique, allowing us to understand how different codes can make a buzzer behave in various ways and how it can be controlled by other components. For the buzzer lessons, we first did the buzzer beep on button press, where the buzzer only sounded when the button was pressed. Next, we worked on a melody player with a buzzer, where we programmed it to play a tune. The third activity was the SOS Morse code with a buzzer, which taught us how to use timing in code to produce Morse-like patterns. We originally completed this activity in real life, but unfortunately, we lost the recorded video. So, as an alternative, our group decided to recreate the activity through a Tinkercad simulation, ensuring we could still demonstrate the concept and process effectively. After that, we made a light-sensitive buzzer alarm, using a photoresistor to make the buzzer react based on the light level. Then, we tried the buzzer sound controlled by a potentiometer, where turning the knob changed the buzzer's tone. Moving on to lesson 3, 7-segment display. We first learned how to display a single digit. We displayed the number 3. And then we created a sequence that displays numbers from 0 to 9. Aside from the required activities, we also made some extra tasks that combine what we learned from the past topics. For task number 1, 7-segment, we created a countdown timer with a blinking 0 and a buzzer. After the countdown reaches 0, the display blinks 0 5 times before activating the buzzer. The buzzer then plays the melody of Twinkle Twinkle Little Star. Originally, the task in the document only required a simple countdown timer with a blinking 0, but our group decided to explore and experiment further by adding a buzzer to also include the buzzer activity Custom Melody Challenge. For task number 2, LED, we created a traffic light simulation using 3 LEDs. Each light turns on and off in sequence, mimicking the timing of an actual traffic light circuit. Overall, through these activities, we learn not only how each component functions individually, but also how to integrate them into working systems, applying our knowledge in coding, wiring, and timing to design simple yet creative electronic projects.
Some clips in this video are set to time-lapse. so you can see the results of a few mini projects we've done on Tinkercad. We tried out different components like LEDs and 7-segment displays, while learning how they work together in a circuit. We also use this as a chance to practice coding and experiment with the features available on the site.
We also use this time to experiment more with LEDs and 7-segment displays, testing how they respond to different codes and different connections. Through the simulations, we practiced adjusting the wiring, fixing small errors, and observing how changes in code can affect the output. It was a simple but really helpful way to understand how these components work together, and how even small details can make a big difference in making the circuit function properly.
Sometimes, issues may arise when it comes to connecting components and codes. We had some difficulties wiring complex components like the 7-segment display, which we had to look at a guide for just to connect the pins to the right places. We also had to put limited values on certain components like the LEDs and buzzers just for safety and to avoid damages to the device. We also encountered problems when uploading a code to our Arduino Uno, when there are cases that the code doesn't work even though we've checked and corrected errors.
This subject has taught us that with the capability of acquiring the right components and codes, we can achieve advanced technology in our early future, and any issues like errors and failed projects don't stop us from exploring further, attempting to progress through these activities until we get our success.